Everyone. Today we're going to look at the second topic inside Chapter 7, and this one deals with calculations involving radical expressions. We're basically going to start off with some simple examples and then eventually progressively get more and more complex. There are a couple of themes that are going to be through this, and one of the themes is the concept in mathematics, at least, if you have two terms that are essentially similar to each other, then you are allowed to do add and subtract, for instance. There are certain calculations that you want. So for instance, if I asked you to combine the square root of 3 plus another square root of 3, then it's not too surprising that the answer is just that you have two square root of 3's. In the same way that if I said you had an x and you added the second x, you would then write 2x. There's no real difference algebraically to either of those two situations. Now you can progress to do things like, well, if I had 3 root 7 and I add 2 root 7 and then I take away a root 7, well, I have 3 plus 2 is 5, then you take 1 away and I'll be left with 4 root 7's. In the same way that if I said 3x, add another 2x and then take away 1x, that you would eventually say that that was the equivalent of 4x. Now, there are some idiosyncrasies. I'm not sure if that's a good word, but there are some situations that you just have to be aware of. So 3 square root of 2, take away 2 square root of 2's, take away another square root of 2. Now, if you look carefully, you've got 3, but you're taking away 3. You do not write down that you have 0 square roots of 2. That mathematically is really not very sensible way of saying it. We just say 0. And if you were doing, say, 5 square root of 7, take away 4 square roots of 7, you wouldn't write down you had 1 square root of 7. Mathematically, we would just write down a single square root of 7, and everyone recognises that as you have 1. Now, what we've just done here is basically add and subtract radicals. You can do that for any radical. So the cube root of 7 plus 2 cube roots of 7 would get you 3 cube roots of 7. And 2 fourth roots of 11, add 3 fourth roots of 11, take away 1 fourth root of 11. That would leave you 2, 5, take away 1. That would leave you with 4 fourth roots of 11. Just as I think it would make sense that that's what you would get. Now, in all these questions, they all share one common theme, that all the radicals in each of these calculations are the same radical. Well, if we move kind of up the food chain a little bit and we look at a more complicated situation, it is possible to combine, to add or subtract 2 square roots. The square root of this guy, take away the square root of that guy. Now, to do that, we need to refer you back to yesterday's, and where we look at what are called square numbers. And square numbers are things like the square root of 4, right? And so 4 is a square number, 9, 16, 25, 36, 49, 64, 81, and 100, and essentially going forever. So when you have 2 square roots that are being added or subtracted, but they are not already the same square root, this is a 98, this is a 162, what you need to do first is convert them. So I'm going to simplify the square root of 98. And I do that by looking at this list of square numbers, and I need to find 2 numbers that multiply that give me 98 and are in this list. One of them's in this list and the other is a whole number. And if I go through them, if I get to this one here, I can see that 49 times 2 gets me 98. If you want to check that, just take 98, right, and divide it by 49, and the answer you get is 2, right? So 49 times 2. That then splits as the square root of 49 times the square root of 2, and that gets me 7 square root of 2's. Now, if you're doing 162, you'll be able to eventually notice that this can be written as 81 times 2, which then splits as 81 times 2 that way, and that gets me 9 square root of 2's. So my original square roots weren't the same, they didn't have the same radical. Now I've converted them into this, and 7 of these take away 9 of these means that the answer is -2 of these, and that's the answer. We are finished. So if you were given a question, let's say like question 7, where you're being asked to combine, well, let's do question 6 first, where you're being asked to combine the square root of 147, take away the square root of 243, we need to convert these into simpler square roots. Right, 147. So, could it work with 81? I'm pretty sure it doesn't. 64, I'm pretty sure it doesn't. It might work with 49, I think it does. So 147, if you divide it by 49, you get the answer 3, so it does. So it's 49 times 3, which is the square root of 49 times the square root of 3, so I get 7 root 3's. Now if I go over here and I do 243, I'll find out that that's 81 times 3. That simplifies down to these two guys, which now gets me that guy, and a rather remarkable result. 7 root 3's take away 9 root 3's, leaves me -2 root 3's. So we are good. We have simplified square roots. Well, I wonder if we can take that a little bit further and maybe do an example like question 8, where it's 2 lots of the square root of 175, take away 3 lots of the square root of 125, add the square root of 343. Okay, so I'll start with this one. The square root of 175, I believe you can do a 25 on that. So let's see, 175 divided by 25, and it works. So I get 25 times 7. So that gets me 2 times square root of 25, square root of 7, 2 times 5 times the square root of 7. So that guy gets me 10 square root of 7's. Let's do the middle one. This guy gets me 25 times 3. So let's take away 3 times square root of 25 times the square root of 3. And I said 3. Let's check that out. Should be 5. There, that's better. And that's -3 times 5 times the square root of 5. So that's negative square root of 5's. And 343. That's a challenge. I'll try 81, I should say. If I divide it by 81, that doesn't work. I know it's not going to divide by 64 because it's odd and even numbers don't divide exactly by odd. So I'll try 49 then. So 343 divided by 49, and that works. So what you get here is 49 times 7. And that gets you the square root of 49 times the square root of 7. And that gets me 7 times the square root of 7. Now we're at this point here. And what I'm going to do is what we typically call collecting like terms. So I have 10 of these plus 7 more of these. So they join to get me 17. And I have that much root 5s. And no, you are not allowed to combine these and make, I don't know, 2 root 2s or anything. These are considered different terms. They are not alike, and therefore you cannot add or subtract terms which are not similar. So you leave them alone, you call it done, you are finished. Now, in the same way that you can combine, add and subtract square roots, you can also do that with cube roots. But in order to do cube roots, we have to set up a set of perfect cubes, just like we did for the square roots. I'll fold this over so it's not going to distract us. We can do the cubes. So 2 times 2 times 2 is 8, for instance. Then 3 times 3, and then all the 4s, and then all the 5s. You can see these go on forever, but there's a lot fewer numbers to choose from when you're doing cubes. So in question 9, we're being asked to find the cube root of 320 and add it to the cube root of 625. It's quite an interesting combination. So what we're going to look at is that they're not the same, right? So I can't just add them together. I have to do a bit of work on them. Let's see what we get here. Cube root of 320 is going to have to be changed, and the cube root of 625 is going to be changed. Well, I know that this guy here works with 125, so I'll just check how much it is. 625 divided by 125, and that's what I get 5. So I get 125 times 5. And 320, I believe, works with 64. Let's find out. 320 divided by 64, and that works. So what do I get? I get 64 times 5. Now this one breaks down into the cube root of 64 multiplied by the cube root of 5 added to the cube root of 125 times the cube root of 5. The cube root of that is an exact value, which you can check on your calculator, but it's 4. The cube root of this guy, again, you can check it on your calculator, is 5. 4 of these guys plus 5 of these same guys gives me 9 of these guys. And that is what these two cube roots add together and give us. So let's try one more cube root with the number. So suppose I have the cube root of 40, take away the cube root of 135. Right, so I'm looking for two numbers that multiply to give me 40, and one of them has to come from this list. It's pretty obvious because that's such a small number, it has to be 8. So that's going to be 8 times 5. Now I'm looking for 135, and 27 works. Just to double check on that. 135 can be divided by 27, and it's 5. So this one's going to be 27 times 5. This splits into the cube root of 8 multiplied by the cube root of 5. Take away the cube root of 27 times the cube root of 5. That guy, check it, your calculator, is 2. So you get 2 cube root of 5. And this is 3 cube roots of 5. And 2 take away 3 of this leaves you with -1. We don't write the 1 down, we just write negative cube root of 5, and that is us finished. And we now have combined those two cube roots. Let's do the same process back to square roots now, but we're going to do square roots involving variables. So the square root of 162x, take away the square root of 128x. And I'm going to break that into the square root of 162 times the square root of x and the square root of 128 times the square root of x. And each of these numbers, these square root numbers, is going to be simplified. So if I look at this guy, it can be split as an 81 times 2, which then becomes the square root of 81, the square root of 2, and the square root of x. The square root of 81 is 9, and these two become a single square root. Now we take this fella, and you get 64 times 2. You get square root of 64 times square root of 2, square root of x. That gets you 8. Combine them to a single square root. And 9 of these guys, take away 8 of these guys, leaves you with one of those guys. And that is your answer. Try a little bit more difficult version. For instance, question 13. And hold on. Right, question 13 then is 2 lots of 7 square root of 7x cubes plus 4x times the square root of 28x. So let's see what this looks like. It's 2 times the square root of 7 times the square root of x cubed plus 4x times the square root of 28 times the square root of x. So I'm kind of breaking it into pieces. I'm going to simplify each piece as much as I can, then tidy up. Well, can't do anything to that, can't do anything to that, but I can simplify the square root of x cubed. And that was based on the last week's work, which basically it goes in once and one left over. And I can simplify out of this whole thing. I can only simplify the square root of 28 by calling it 4 times 7. Now, what I have here is 2x and combine the square roots, so that's what that becomes. So a little bit more going on here. I'm going to have 4x, square root of 4, square root of 7, square root of x. That's going to be 2 square root of x and 7. 2 and 4 gets me 8. I'm going to have an x, and I combine them. I have that. And I've already simplified this guy, so there you go. And we are looking at this guy plus this guy. And you notice that they're the same. X square root of 7x's, x square root of 7x's. You've got 2 of them, you've got 8 of them, so you combine them, you have 10 of them. Now you're only allowed to do that because they are similar terms. They both contain the same pieces, just different amounts. This has 2, this has 8, combined you get 10. Okay, let's continue that process. Let's try subtraction. Let's do 14. We're going to have x, the square root of 108xy, take away the square root of 12x cubed y. So I'm going to take each of these pieces, break them apart, take each of these pieces, break them apart. If there's anything that can be simplified, I should do that. Well, there's only one term I can say, and this is the 108. And somebody in here is going to get me 108. and it's 36 times 3. You can check it out, but it does work. So 36 times 3. So that's going to be x times, I'll save a line of working. That's going to be 6 and a square root of 3, and a square root of x, and a square root of y. And that can go there, and these 3 guys become a single square root. Now, this guy can be simplified by calling him 4 times 3, which is going to get you 2 root 3. This guy can be simplified as an x square root of x. And this guy can't do anything with. So I'm going to have this guy and this guy, which is 2x, and these all combine inside their own square root. And this fella and this fella are similar. So 6 of them take away 2 of them, leaves me with 4 of them. And we have finished combining, in this case adding and subtraction, of quite ugly looking radicals with variables in them. So let's look at multiplication now. So the first one in the homework that has multiplication is a version of 15, where we have the square root of 6 times the square root of 10. Now, normally what we would do in add and subtract, for instance, is we try and simplify these, multiply them together, and then tidy it up. But in fact, in this situation, you first multiply the 2 together. So the square root of 6 times the square root of 10 is the square root of 60. And now you can start looking for somebody in this list that hopefully works with 60. That's who we're looking for. And the only one I could find was 4 times 15. That one. And that becomes the square root of 4 times the square root of 15. And there is your final answer. So if you want to combine 2 square roots multiplied together into a single square root with a, in this case, square root of 15, this is the process. So if we try 16, you're going to have 7 times the square root of 14 times 8 times the square root of 7. And what I'm going to do is multiply the 2 numbers together. 7 times 8 is 56. And multiply the 2 square numbers together. So in this case, it's going to be 14, oops, put that on, 14 times 7, and I'm going to get 98. So once you've multiplied them, combined them into a single expression, you then essentially simplify. Well, I know that the square root of 98 is 49 times 2. We'll check it. That becomes 56 times the square root of 49 times the square root of 2. So that becomes 56 times 7 times the square root of 2. And 56 times 7 is just a massive number. And it's 392 square root of 2. We're finished. Now, if that was a negative, then all that we would have would be a negative. That's all it does. So negatives in the usual sense of things don't really change anything. I suppose you want to multiply a cube root. So we know we're going to use cubes when you do cube root questions. The first one that you're asked to do that is question 18. So we're looking at the cube root of 9 times the cube root of 18. So I'm going to multiply them on my calculator. And 9 times 18 ends up being 162. And that guy is the cube root of 27. Let's try that. 162 does work with 27, and it's that guy. And we split them now as a cube root of 27, perfect cube, times the cube root of what's left over, which is a 6. And the cube root of 27, you can check out your calculator, is 3 times that guy. Actually, you don't need to write multiplication. You just write that. That's your answer. Now, if you stick a negative there, makes the answer negative. That's all. Doesn't really do much. And so, very similar to what you do with cube roots. Let's move on to back to square roots again. And let's look at more complicated versions, even more so than what we've already said. So we have an x squared y to the 5 times an xy. First thing I'm going to do is just combine them into a single square root. So x squared times x gets me x cubed, and y to the 5 times another y gets me y to the 6. Now that I've got a single square root, I'll now proceed to simplify it. Break it into its two separate pieces. The square root of x cubed, well, if you do 2 into it, you get 1 and 1 left over. So that's the answer. And divide that by 2 and you get a perfect match. And we typically put those guys first and finish with a square root. We move on to something like, say, 22. We have the square root of 5x squared y times 3125. What a ridiculous question. But it doesn't really matter how ugly it is. It really doesn't. As long as you stick to the rows, you're fine. So 5 times that huge number, I'm just going to go 3 times 3,125. And that gets me 9,375. An x cubed and a y squared. Well, that's going to break apart as 9,375 times that guy times that guy. Let's check something out here. The square root of 9,375. Let me check that. 5 times 3,125. Oh, okay. That multiplication was wrong. That's why it didn't work. If you multiply these two together, you get 15625. And now I'm going to try the square root of 15625. And that's actually a perfect number. 725. Now this guy, well, if you want to square root, you half the power, that gets you 1 and 1 left over. You half this power, which just basically gets you a y. You now have 125 xy and 1 square root left over. And that is the end result of that one. Let's do a question 24, where it's going to be 2 times that square root, 3 times that square root, and 3 times that square root. Okay, what can we do? Well, I can go 2 times 3 and get 6, and then everything else can go in the square root. 2 times 32 times 3 is going to be 2 times 32 times 3 is 192. That guy times that guy times that guy is x to the 6. And that guy times that guy is y to the 4. So one single square root now gets simplified by breaking it into its constituent parts. So we've got those guys. Right, I'm looking for a number that works with 192. Let's try 81, just to check it out. Does 192, does it divide exactly with 81? No. Okay, so how about 64 then? 192 divided by 64. That one works. So 192 is 64 times 3. Now, half x to the 6 gets you x cubed, and half of y to the 4 gets you y squared. This fella becomes the square root of 64 times the square root of 3 times what's left over. This becomes 8, so it's 6 times 8 times that guy, times that. And those numbers are 48. Then you have an x cubed, y squared, and finish with a square root of 3 at the end. And that is combinations of multiplications with square roots. Let's do combinations now involving cube roots. So we know we're going to maybe use some cube numbers. First one of this type is similar to question 25. So it's a cube root of 8ab times cube root of 4a squared b cubed times a cube root of 9ab to the 4. Now, as a single cube root, that's going to be a lot of work. So here goes. 8 times 4 times 9. So let's do that. 8 times 4 times 9 gets me 288. There's an a times an a squared times another a, so I believe that's a to the 4. There is a b cubed, and a b to the 4, which I believe is b to the 8. So that's what we've got. Now I'm going to split it into the cube root of each component part. Now, 288. It has to be somebody, but what? Let's see if we can find someone. Well, I don't think I need to try 125. That's a non-starter. Let's see if 288 can be divided by the perfect cube 64. No, okay. How about 288 being divided by 27? Nope. How about 288 being divided by 8? There we go. So it's the cube root of 8 times 36. Now, these two guys are just basically, if you take 4 and divide it by 3, you get 1 and 1 left over. 8 divided by 3 gets you 2 and 2 left over. 2 and 2 left over, 1 left over. Now, this becomes the cube root of 8 times the cube root of 36 times this guy times this guy. And the cube root of 8 is 2. So we've got that guy. We've got this one. And finally, this one. So we have a 2, we have an a, and we have a b squared. And then everything else gets put into a cube root, a single cube root. 36 a b squared. We're finished. Okay. Where are we going next? Well, let's do some multiplications, but ones with FOIL and the distributive law. So we're back to square roots. So first one I'm going to try is say question 26, where it's the square root of 21 times the square root of 21, take away the square root of 3. Well, according to distributive law, you multiply those two, you multiply those two, so we should do that. 21 times 21, rather large number, but it's 441. Take away the square root of this times the square root of that is 63. Especially if you get a big number, it might be worthwhile just to check out if it's not a perfect match. And I know that this one is actually 441. And the answer is it's exactly 21. So this one is just a number, which is nice. This one, I think I can simplify it. I just have to figure out what combination is going to work. And the one that works is 9 times 7. So it's square root of 9 times square root of 7. 3 square root of 7s, and that's as good as the answer's going to be, because 21 is a number, and that has got a root 7, right? They're not the same, they're not similar, so you can't do anything about adding or subtraction. They are finished. You can, of course, multiply things that are not similar. That's allowed, but not add and subtract. So next one we will do is 28. And this time we have square root of y times the square root of y, take away square root of 5. And we'll multiply. The square root of y times the square root of y gets me the square root of y squared. And the square root of that times that gets me negative the square root of 5y. And this guy actually is y. And this guy, you can't do anything, so you're finished. And yeah, I know that's a y and this is a y, but that is not inside the square root, and this is. So mathematically, they are not considered similar. And so you're finished. If things are not similar, you cannot add, you cannot subtract. You just leave them alone. Question 30 then. A little bit more work. We could do this one. So multiplication, right? That times that's going to be a bit messy, but 3 times 27 gets me 81, and a times that guy gives me 8 to the 5. Take away this guy times this guy gets me the square root of 3 a squareds. This fella splits as an 81 times the square root of 8 to the 5, and this splits as the square root of 3 times square root of a squared. Now that one is a perfect match, so you get 9. And this guy, well, if you half the power, you get 2 and 1 left over. And this guy, you get the square root of 3 times a. And they are not similar. So you can't do anything about. The best I could do is maybe slightly rearrange the way it's written, but I'm not really changing anything. So that's as good as that answer can be. So for the last phase of the questions, we are going to do a very specific situation. It even has its own name. It's got a fancy name. It's called rationalizing the denominator. Rational the denominator. Essentially, if you get, let's do an example. If you get a fraction with a square root in the bottom, like that, we don't consider that to be a very simplified version. Square roots in the bottom are considered bad form. So the way you work is, I'm going to multiply this by a special version of 1. right? Square root 11 over square root 11 is just the number 1, right? It's a fraction written as 1, right? Now, if you multiply the top together, and you multiply the square root 11 by the square root 11, you get that. No, you're not allowed to cancel them. That's the final answer. At least it doesn't have a fraction, a radical in the bottom. That's all. No rationals, right? No radicals. And if we move on to, say, 32, we have a little bit more going on here. The only term that's important to get rid of is this square root. That 3 doesn't matter. Square root of 7 then, times top and bottom. Well, these two will get you 35 root 7. And this gets you what? Square root of 49, which is essentially 7. So you get 3 times the square root of 49. So you get 3 times 7. So you get, this is just one way of doing it, you get that guy. And then you say, wait a minute, I can divide that by 7 and that by 7. And now you've got an even nicer version of the answer. There, that's you finished. Try a few more of these. Question 33 has a 10 on the top and a 7 square root of 5 on the bottom. So I'm going to multiply by that special version of 1 because the square root of 5. The top two give me that. And let's save some time. A square root of something times itself just gets you the number. So the square root of 5 times the square root of 5 eventually becomes 5. So you end up with 7 times 5. And that gets you 10 root 5 over 35. And then you notice that you can divide this by 5 and that by 5. And so you finish with that guy. There is a slight alternate way of coming up with the same answer. At this point here, you might notice that you can divide top and bottom by 5, and that leaves you with 2 root 5 on the top and 7 times 1 on the bottom, and you've saved a line of working, and if you can handle that, that's great. So this fraction, when you simplify it, ends up being this guy. So how about this question? We're being asked to simplify that fella. Well, square roots can be split. So this is equivalent to that. What I really have now is a fraction with a square root in the bottom. So let's rationalize the denominator, because we only worry about what the bottom is. We don't really care too much what the top is. So 28 top and bottom. Now these two square roots actually can be multiplied to a single square root of 140. And the square root of 28 times the square root of 28 just gets you 28, right? And we should always be on the lookout just in case, because you're never sure what you're going to get, and see if you can do better. And I think you can do 140 as 4 times something. Let's see if that's the case. 140 divided by 4. And the answer I get is 35, so yes, you can. Now that guy will get you 2, and that guy will get you square root of 35. And now I'll cancel this one with that one by dividing both of them by 2. And what's left is the square root of 35 over 14. And there is your answer. And that's pretty much us. So, as always, I hope this has been of use to you. And goodbye until the next time.